Hi friends, welcome to our channel. So in this video, we are going to discuss about what is dynamic method dispatch and what is the real life usage of dynamic method dispatch in Java. Before getting into this video, to understand dynamic method dispatch, so we must be familiar about inheritance and overriding concept. So in our previous video, already we have discussed inheritance and various type of inheritance in Java as well as overriding and its real life usage of overriding in Java. So in case if you haven't watched those videos, so the link is available in the description. So please watch those videos so that you will be getting a clear understanding about dynamic method dispatch. Now let us get into this dynamic method dispatch. As we know, or as I mentioned in the beginning, to make a dynamic method dispatch, we need inheritance as well as overriding concept. Let me take a very simple inheritance and overriding concept. Let me take a class vehicle, and in that vehicle class I'm going to define a method wheels. I'm using the same example which I used in our overriding video. So already we know that inside vehicle class I cannot define number of wheels. Yes, the number of wheel is going to be vary based on my subclass. So in vehicle class, I can give a generic definition. So I will say vehicle has wheels, or I can say all vehicles having wheels. Let me say I have a wheels. So this is a generic definition. Yes, inside vehicle class, I cannot define how many number of wheels. Simply, I can give a generic definition saying that all vehicles have wheels. Let me define a subclass. Let it be bike. So, which is extending this vehicle class. And in this bike class, I am overriding my wheels method, and I will say I have two wheels. So finally, we have our inheritance as well as overriding. So now I am going to apply a dynamic method dispatch. With the help of dynamic method dispatch, or in short you can say DMD. With the help of this DMD, I can assign subclass object to superclass reference. So this particular assignment will called as dynamic method dispatch or DMD. So far what we have done, we have created a reference and object as a same type. But now what I am going to do, I am assigning subclass object to superclass reference. My reference is super type, but the object is subtype. So this is nothing but your DMD, dynamic method dispatch programmatically. So this DMD is possible if there is a inheritance. So if there is no inheritance, then I cannot use DMD. So that's why I'm saying that DMD is nothing but it's a process of assigning subclass object to superclass reference. So now the reference is super type, object is subtype. Now by using this object, I'm trying to call a overloaded method. We as you know that as per this code, wheels is a overriding method. Already we have discussed in our previous video, overriding is based on object. So the overridden method will identify during runtime by using object. Now let us run this code. My reference may be vehicle type, but my object is bike class. And I'm trying to call wheels, which is overridden method. Overriding is completely based on object. So that's why it is displaying a method from, or it is executing a wheels method from bike class because it is overriding, and overriding is based on object. Now we'll move little more depth. I'm going to define one more method in my vehicle class. This method is going to talk about number of engine. Just assume that in my vehicle class, I'm defining one more method, and this particular method is going to define number of engine. So already we are familiar for all the vehicles we have only one engine. So I will say system.out.println I have one engine. In case of wheels, I have to override. In case of wheels, I have to override because this number of wheels is going to be vary based on my subclass. If it is bike class, it will be two wheel. If it is car class, it will be four wheels. If it is auto, then it will be three wheel. But this number of engine, I no need to override because commonly all the vehicle will come with one engine. So finally this engine method I no need to override. So finally you can look at right now my current code. I have a overriding method wheels as well as I have a non-overriding method engine. As per the DMD, your overriding is based on object, the non-overriding is based on reference. So please understand this point very clearly, friends. So coming to overriding, what we are doing, we have a superclass reference and it is pointing subclass object. So reference is supertype, object is subtype. So coming to this DMD, I have two things. One object is subtype, reference is supertype. So here overriding is based on object, non-overriding is based on reference. Now let me try to invoke engine method. So engine is non-overriding. It's a non-overriding method. Non-overriding is based on reference. So which means it will call engine method from superclass. But wheels is a overriding method. It is based on object and it is going to call wheels from subclass. So it's look like a object slicing. I'm getting some property. I'm getting overriding property from my subclass and non-overriding property from superclass. So it's look like object slicing. Some amount of property I'm going to get from subclass and some amount of property I'm going to get it from my superclass. Right. So this is about DMD. So now you may get a question, can I do it in a reverse? Like bike class reference equal superclass object. Let us try and we'll observe the error message. It is saying that you can look at the error message. It's clearly saying that type mismatch cannot convert from vehicle to bike. To avoid this compile time error, maybe I can go for typecasting. I can go for the typecasting to overcome this compile time error. But even though during runtime, it will throw the exception called class not found, class cast exception. So finally, the reverse of DMT is not possible. So the reason is very simple. In real time, there is no scenario for the reverse. I can say all bikes are vehicle. I can say all bikes are vehicle, but I cannot say all vehicles are bike. The same way you can take one more scenario. Fruit is a superclass, apple is the subclass. I can say all apples are fruit, but the reverse I cannot say. I cannot say all fruits are apple, right? So that's why the reverse of DMD is not possible. Let us run this code and we'll observe our output, whether it is producing the output as per our discussion or not. You can look at the output. Non-overriding is invoking from my superclass based on reference, and overriding is getting invoked from my subclass based on object. So this is DMD or dynamic method dispatch in Java. Let us modify the code slightly so that we will understand what is the real usage of DMD in a real life. Let me change this method return type as string, and here I am going to return a string value. Right, just I'm just modifying the code. Anyhow, it's a non-overriding, so I'm just modifying code as per my requirement. Otherwise I can make it void itself in case I don't want to change too much. Let us make it as void. Let us keep the same code. So now what I am going to do, I'm just going to add some more two more subclass, nothing but hierarchical inheritance. I will say class called extends vehicle, and I will be overriding only wheels method, and here I will say I have four wheels. As usual, as like bike class, I no need to override engine method because it's all the vehicles is having only one engine. The same way, let me add one more class. Let it be auto, which is extending again vehicle class. Nothing but our hierarchical inheritance. One superclass, multiple base class, or sorry, one superclass, multiple subclass, nothing but our hierarchical inheritance. The same way in auto class also I am overriding wheels method. I will say I have three wheels. So finally you can look at the scenario. I have a class called vehicle. It has one common method or non-overriding method engine. It is going to say one engine, and I have a wheels method, and number of wheel is I cannot define in my vehicle class. Yes, it is going to be vary based on my subclass. In my subclass, I'm overriding, and based on my subclass, I'm giving a definition. Bike is two wheel, car is four wheel, and auto is three wheel. Now, let us come to our main class. I'm going to apply a DMT and a slight different scenario. Let me remove all those things. What I'm doing, I'm declaring a vehicle class reference as common, and during runtime or on the fly of the application, based on the customer demand or customer requirement, this reference is going to point either bike object, or it may point car object, or it may point auto object. So now I hope you are getting little bit idea about the real life usage of DMT. So finally you can look at the code. I have a common reference, superclass reference. During runtime, based on the customer requirement or based on the customer demand, on the fly, it may point bike object or car object or auto object. So right now you can look at this code. This reference is pointing bike object. So now by using this reference, if I call engine method, it is a non-overriding method based on reference. From superclass it will display I have one engine. And same way if I call wheel method, which is overriding is based on object. So right now my reference is pointing bike object, which means it will be displaying bike's number of wheel. And later the same common reference can provide a service for car, as well as it can provide a service for auto based on the customer requirement. Let us run this code and we'll observe the output. You can look at the output. First, it is providing a service for bike. It is displaying two wheels. Second, the same reference is pointing car object and it is providing a service for car. And third, the same common reference is pointing auto object and it is providing service for auto. So this is the real life usage of dynamic method dispatch. So finally, with the help of dynamic method dispatch, what I am doing, I am making a common reference for a super type, and during runtime this reference can provide a service for bike or car or auto based on my customer need or the requirement. So finally, to achieve this DMD concept, yes, obviously we need inheritance as well as overriding concept. So finally, I am summarizing the point once again. By using DMD, I can assign subclass object to superclass reference. Here, overriding is based on object, non-overriding is based on reference. So what is the real life usage of DMD? I have a common reference. I will be creating a common reference, and that common reference is going to provide a service for any type of subclass object, or it can handle any type of subclass object based on the demand or based on the customer requirement. You can take any real-time scenario, it will come with dynamic method dispatch. Let us take a very simple example. Uh, so we know that we have a mechanical person, right? Suppose if I am going to a mechanical shop with my bike, so the mechanic person will be the single person. He is the single reference. If I am going with bike, then he will provide a service for bike. He can check my bike fault and he can repair it, right? And same way, the next customer will go to the same mechanic person or mechanic shop. He may go, the next customer may go with the car. So the single reference or the single mechanic person will provide a service for car, and same way another customer may go with the auto. So now the another person is going to, the mechanic person is going to provide a service for auto. So finally the mechanic person is a common person. During on run time or on the fly, he can provide a service for various vehicles based on the customer. The same way you can take one more scenario. So we are going to a restaurant, right? So the restaurant service provider guy is a single guy. For example, let me assume that for a particular table, he is the only one person. So he is a common person for the particular table. When I go to that same restaurant, I may order dosa. So he will provide a service for dosa. And next somebody will go to the same restaurant, same table, and the same common person is going to provide a service for the particular table, but the second person may order some other food. So finally he is a common uh, person, but he is providing various different type of food service based on the customer demand. So finally, each and every real-time application will come with dynamic method dispatch. So finally, with the help of this dynamic method dispatch, I will make a common reference. So that common reference is going to provide a service for different object based on the customer requirement during runtime. Same way you can take your e-commerce website call center guys, right? I may call to the call center guy regarding a product X. He will provide a service or he will answer the query for a product X. The same call center you may call and you may get a service for product Y, and another person may get a service for product Z. So finally, he is a single service provider guy. So he can provide a service for various, or he can answer the queries for various products. So one reference, multiple service. So that's a real life usage of dynamic method dispatch. So hope friends, so we are clear about what is dynamic method dispatch and how to achieve dynamic method dispatch in Java. Also, we understood that what is the real life usage of dynamic method dispatch. Thanks friends for watching this video. So if you like this video, please subscribe and click on the bell icon so that as soon as I upload the new video, you will be getting the notification. Also, you can share it with your friends.